Not many know much about North Korea's space agency. This mysterious organization claims to be advancing in space, but what's really happening? Let's explore the truth behind North Korea's space ambitions. North Korea's evolving space launch capabilities. North Korea is known for its strict and inflexible approach to governance, from its tight control over emigration to its harsh labor camps. A key aspect of its international profile has been its missile and rocket development, which has been a cause of global concern for decades. Despite international pressure to denuclearize, North Korea's advancements in missile technology continue to draw attention. As global powers like the US push into space with initiatives like the Space Force, one might wonder if North Korea can keep up with these advancements or if its nuclear program represents its final major technological effort. North Korea started its space program later than other countries. In the 1980s, they set up the Korean Committee of Space Technology to handle space projects. Their first big task was to build a launch site, the Jong-il Satellite Launching Ground, in North Hamgyong Province. Construction was slow and took place in fits and starts during the 1980s and 1990s. By 1985, the launch pad was finished, but it only had basic facilities like a command bunker, radar, and some support buildings. At first, the goal was to copy Soviet Scud rockets, so this basic setup was enough for their needs. In the 1990s, the North Koreans made significant upgrades to the Jong-il site. Reports indicate that the facility expanded from 2 kilometers to 9 kilometers in length. New additions included a missile assembly plant, fuel storage, a guidance and control center, and tracking stations. Following the Jong-il site's expansion, North Korea focused on developing a new launch site, the Sohae Satellite Launching Station. Construction of Sohae began in the early 1990s, but faced delays similar to those of Jong-il. The site was not completed until 2011. The Sohae facility is much larger, covering 6 square kilometers, which is 5 times the size of Jong-il. It is also more advanced, featuring a static rocket motor test stand and a sophisticated mission control center, replacing the rudimentary command bunker used previously. Taepodong Missile Program. North Korea has conducted 3 major space programs to date, starting with the Taepodong project. The Taepodong program aimed to replicate the Soviet Scud rocket, a tactical ballistic missile. Initially, there were concerns that North Korea might use Taepodong as a surface-to-surface missile. However, the US Defense Intelligence Agency later proposed that Taepodong served as a testing platform for developing advanced multi-stage missile technology. In August 1998, North Korea launched Taepodong-1. According to North Korean sources, Taepodong-1 successfully reached orbit within 5 minutes of launch and placed its first satellite into space. However, Western scientists disputed this claim. They observed that while Taepodong-1 did achieve an altitude of 200 kilometers, the third stage likely failed to ignite, preventing the satellite from reaching orbit. Estimates suggest that, if successful, Taepodong-1 could have had a range of up to 5,900 kilometers. North Korea's second attempt was the Taepodong-2, launched in July 2006, nearly 8 years after Taepodong-1. Although there is no available footage or images of this launch, the US Department of Defense confirmed it took place. Unfortunately, the missile failed just 40 seconds after liftoff. Despite the failure, it is believed that Taepodong-2 had improved power compared to its predecessor. Each stage of the missile might have had a burn time of approximately 100 seconds, potentially allowing for a total burn time of 5 to 6 minutes. This improvement could have given the missile a range of up to 9,000 kilometers and a payload capacity of around 500 kilograms. North Korea's Unha rockets. North Korea's aspirations to develop advanced rockets faced many challenges, leading them to adopt a new series called Unha. The Unha, which translates to galaxy, is essentially a patched-together rocket combining various elements from existing models. Its first stage uses 4 enlarged Nodong engines, which are based on Scud motors. Initially, it was believed that the second stage was inspired by the Soviet SSN-6 missile, but it is now widely accepted that it is also derived from the Scud rocket. The third and fourth stages resemble the Iranian Safir rocket's second stage. This suggests that North Korea largely relied on existing designs, rather than creating something entirely new with the Unha rocket. The Unha rocket caused a significant controversy. The United Nations had banned North Korea from testing ballistic missiles with Resolution 1718, but Unha is a ballistic missile. This launch was seen as a violation of that ban. The US, South Korea, and Japan were worried, and even Russia asked North Korea to stop the launch. Despite these warnings, North Korea launched the Unha-2 on April 5, 2009. South Korea said the rocket's first stage fell into the Sea of Japan, and the rest landed in the Pacific Ocean. The rocket traveled about 3,850 kilometers, but the US thought it might not have reached orbit. North Korea claimed the launch was a success and that they put a satellite into orbit. The next Unha launch, Unha-3, took place in April 2012. North Korea was very optimistic about this launch and even invited observers from 8 countries to watch. Unfortunately, the launch failed. While details of the failure are unclear, it was evident that North Korea was close to a successful satellite launch. 8 months later, in December 2012, another Unha-3 rocket was launched. This time, North Korea successfully placed a satellite into a sun-synchronous orbit. While this was a significant achievement, the satellite did not transmit any data as expected, and astronomer John McDowell from Harvard noted that it was tumbling uncontrollably in orbit. Following this partial success, North Korea decided to rebrand their space efforts. In April 2013, they established the National Aerospace Development Administration, NADA. The name, which coincidentally means nothing in Spanish, has become a running joke in the media. The most recent Unha-3 launch occurred in February 2016. This launch marked North Korea's first fully successful attempt. The head of the scientific research department of NADA confirmed that they had received photographs from the satellite. As of now, there is no evidence to dispute this success. Thus, North Korea has demonstrated its capability to launch small satellites into orbit. Capabilities and concerns. North Korea's space program, known as the Kwangmyongsong program, involves a series of satellites designed primarily for communication and Earth observation. These satellites were initially developed with China's assistance, and North Korea has since worked on refining the Chinese design. To date, there have been 4 satellites launched under this program, 2 of which have successfully entered orbit, though one has experienced issues with its orientation. The current knowledge about North Korea's space activities is limited, but concerns about their potential for space-related threats have been addressed by experts. The Center for Strategic and International Studies at Georgetown University has identified 4 primary areas of concern related to North Korea's space capabilities. First, there's the potential threat from kinetic anti-satellite (ASAT) weapons. These are designed to physically destroy satellites in orbit. However, North Korea has not tested or publicly announced any progress in developing such technology. According to CSIS, the country faces significant technical challenges that would make the development of effective kinetic ASATs unlikely in the near future. Second, non-kinetic counter-space weapons, such as nuclear devices detonated in space, have been discussed. Some reports suggest that North Korea might be working on such technology. Nonetheless, there is no concrete evidence of successful tests, and CSIS doubts North Korea's ability to develop this technology independently without assistance from nations like China or Russia. If North Korea does possess such capabilities, they likely came from external sources rather than domestic development. The third category involves electronic counter-space weapons. These are technologies that can disrupt satellite signals, such as GPS and communication channels. North Korea does have the capability to jam signals and has been doing so against South Korean satellites since August 2010. This activity breaches the 1953 Armistice Agreement, but the international community has largely chosen to overlook these violations, as signal jamming is considered more of an annoyance than a severe threat. Lastly, there are cyber counter-space weapons. This includes hacking into satellite systems to either steal information or insert false data. North Korea's cyber capabilities are strong, particularly since Kim Jong-un's leadership. Despite this, Western nations maintain a technological advantage in cyber warfare. That's all for this video.